Welcome to my class on reaction rates, kinetics. In this introduction of this one, we have some small exercise that is think about some of the following reactions: rusting of metals, photosynthesis, weathering of rocks. That means limestone rocks being weathered by water, combustion, and all these things. For each of these reactions above, if you can write a chemical reaction that takes place, how fast is each of these reactions, rank them in order from the fastest to the slowest. How do you decide which reaction was the fastest and which was the slowest? Try to think some other examples of chemical reactions, how fast or slow each of these reactions compared with those listed earlier. So if you do this experiment exercise, you will come to know these are the values. That means we got after the experiment, that is the rate of the experiments. In a chemical reaction, the substances that are undergoing the reaction are called as reactants, while the substances that form as a result of reaction called as products. And the reaction rate describes how quickly or slowly the reaction takes place. So how do we know whether the reaction is slow or fast? One way of knowing is to look either at how quickly the reactants are used up during the reaction or at how quickly the product forms. For example, iron and sulfur react according to the reaction. See, this is the reaction we have. Fe plus S gives rise to Fes. In this reaction, we can observe the speed of the reaction by measuring how long it takes before there is no iron or sulfur left in the reaction vessel. In other words, the reactants have been used up. Alternatively, one could see how quickly the iron sulfide product forms. Since iron sulfide looks very different from either of its reactants, this is easy to do. Another example we have magnesium oxide formation, that is 2Mg plus 4 gives us 2MgO. In this case, the reaction depends upon the speed at which the reactant, a solid magnesium or oxygen gas, are used up, or the speed at which the product magnesium oxide is formed. So that means we can study the rate of reaction either with respect to reactants or products. In this experiment also we can understand rate of reactions initial discussion. So what is the meaning of rate of reaction? The rate of reaction describes how quickly reactants are used up or how quickly products are formed during a chemical reaction. The units of this one is the moles per second. That means mole per second, mol, second inverse. We can also use this symbol. So the average rate of the reaction is expressed as the number of moles of reactants used up divided by the total time of reaction, or as the number of moles of product formed divided by the reaction time. Using the magnesium reaction shown earlier, we have the average reaction rate can be written as of magnesium is equals to moles of magnesium used up by the reaction time in seconds, or the average reaction rate of oxygen can be written as moles of oxygen used up by reaction time. As magnesium and oxygen both are present in reactant side, so used up we have to write on the numerator. Whereas when it comes to magnesium oxide rate, average rate of reaction can be written as moles of magnesium oxide produced by the rate of reaction. So in that way you can express the rate of reaction for a chemical reaction. Now we'll see a chemical reaction example. Reaction rate. The following reaction takes place after 2 minutes. 4 grams of lithium has been used up. Calculate the rate of reaction. So here they given the mass of this lithium. Then in the step 1, what we'll do is calculate the number of moles of lithium that are used up. So number of moles formula, that is mass by molar mass. Mass of lithium is 6.94, and using this one 4 by 6.94 got 0.58. And step 2, what we'll do is calculate the time in seconds. They have given 2 minutes. The 2 minutes will be converted into seconds. We got 120 seconds. And the third step, what we'll do is directly substitute these values of number of moles and time in the rate equation, that is equals to moles of lithium used up by time, that is 0.58 by 120, 0.005 got. That is called as rate of reaction, that is 0.005 moles per second is the rate of that reaction given lithium oxide formation reaction. This is one model example. Exercise one more we have, that is Another point here is factors affecting rate of reaction. Here several factors that affect rate of reaction. It is important to know that the factors so that reaction rate can be controlled that are particularly important when it comes to industrial reactions, so that productivity can be maximized. The following are some of the most important factors that affect the rate of reaction. They are nature of reactants, concentration of the reactants, or pressure of the gases when they are taken gases in the reaction, and the temperature also one of the important factor. The nature of reactant, how it impacts means the substance have different chemical properties. That they react differently in different rates. And concentration case is there means that the concentration of reactant increases, what will happen? It does the reaction rate, so reaction rate increases. When it comes to temperature, the temperature of reaction increases, then so does the rate of reaction also increases. Well, that of another fourth important characteristic property factor is nothing but catalyst. If you add a catalyst to the chemical reaction, definitely chemical reaction rate increases when you observe the chemical reaction is a mild reaction. Come to the fifth factor important, where is the surface area of the solid reactants. So increase the surface area of the solid reactants means we will make them into broken parts of solid, that means are finely divided powder, then it will increase the rate of reaction. So these are main important factors. Coming to the activity, what is the meaning of activity of reactants? Means I have said earlier, the reactants surface area can be increased, or we will allow the reactants to participate in the chemical reaction by changing the physical states of the reactants by making them finely divided powders or allowing them to dissolve in aqueous solutions. In this one small experiment, if you see, to determine the effect of nature of reactants on the rate of reaction, a small experiment you will see, that is oxalic acid FeSO4 reaction. That means oxalic acid is H2CO2O4, ferrous sulfate is FeSO4, potassium permanganate is KMNO4, and concentrated sulfuric acid is H2SO4. Spatula, test tubes, medicine, a dropper, and a glass beaker and glass rod. If you take all these things in one test tube, one will take H2SO4 and KMNO4, and test tube 2 we have taken sulfuric acid and KMNO4. And when we prepare these two, the first method is that, but the first test tube we prepare iron sulfide solution, sulfate solution, dissolving about spatula points. After that we have added this iron sulfate up to 10 ml of water. The second test tube, what we did is prepare the solution of oxalic acid in the same way. After that, these solutions are added by 1 centimeter cube concentration, added to 4 centimeter cube of water. Remember, always to do the acid to the water, the never the other way around. So add 2 centimeter cube of sulfuric acid solution to the iron and oxalic acid solutions respectively. Then after what will happen is, using the medicine dropper, add a few drops of potassium permanganate to 2 test tubes. Once you have done this, then observe how quickly solution discolors or decolorizes the potassium permanganate. So what is the result of this experiment in the lab? That you should see how in oxalic acid solution decolorizes the potassium permanganate much more slowly than that of iron sulfate. So what is the meaning of this? Is the oxalate ion is there, C2O4 2 minus, and the iron ions cause the decolorization. That's why it is clear that Fe2 plus ions are much quickly react with oxalic acid. So that indicates that the reactivity of a substance with time interval. Next, the reason of this is that there is no chemical bonds are present, broken ions are there. That's why in the reaction taken rapidly. In the case of oxalate ions, the covalent bonds between the carbon oxygen atoms are there, must be broken faster. The reason why the reaction happened slowly. So what is the fact we observed in the previous experiment is nothing but oxalic acid are abundant in many plants. The leaves of the tea plant, that is the Camellia sinensis, contain very high concentrations of oxalic acid relative to other plants. Oxalic acid also occurs in small amounts of fruits in foods such as parsley, chocolate, nuts and berries. Oxalic acid irritates the living of the gut when it is eaten and can be fatal in very large doses. So this is one of the important fact about oxalic acid, as it is a covalent compound. Coming to another important factor, that is collisions. So what is the meaning of collisions? How it will take place? The nature of the reactants can affect the rate of reaction, and the conclusion of that above experiment is nothing but nature of the reactants can affect the rate of reaction. Now, one more activity we'll see, that is surface area and reaction rates. When you take a marble calcium carbonate reacts with hydrochloric acid, which is the chemical reaction. In this, carbon dioxide is get to be evolved. There is a small aim of this experiment, that is to determine the effect of surface area of reactants on the rate of reaction. 2 grams of marble chips have taken, 2 grams of powdered marble taken, hydrochloric acid beaker, 2 test tubes taken. And this one test tube marble chips taken, another test tube of powdered marble taken. That means you understand the surface area difference in the two substances. So in this method, to prepare a solution of hydrochloric acid in a beaker by adding 2 cm cube of concentrated solution of to 20 cm cube of water. This is one first test tube. Another test tube, you can take place the marble chips in the powdered marble into a separate test tube. Then add 10 ml of this hydrochloric acid to each of the test tubes and observe the rate of at which the carbon dioxide gas is produced. So what are the results observed after the reaction is nothing but which reaction proceeds fastest, can you explain? If anybody asks, then you can tell. The conclusions after the reaction is a reaction with powdered marble is fastest, and a smaller the species of marble or greater the surface area of the reaction to takes place. That's why the greater the surface of the reactants is providing the reaction more fast. We have one more important activity is there in the understanding the rates of reaction, that is the reactant concentration and reaction rate. So as we said earlier, concentration increases, the rate increases. So to find that one has small activities, that is to determine the effect of reactant concentration on the rate of reaction. We'll take some important apparatus and chemicals, that are concentrated hydrochloric acid and magnesium ribbon, 2 beakers and 2 test tubes and measuring cylinder. So what will happens when magnesium and HCl reacts, and a chemical reaction takes place, and finally in the chemical reaction magnesium liberates hydrogen gas from the hydrochloric acid. For this, we have taken 2 test tubes. In one test tube we have taken magnesium ribbon, and another test tube also we have taken one magnesium ribbon, and we have taken 10 ml of HCl in one test tube, another test tube B, that is 20 ml we taken, and the reaction taken place, and finally we got this hydrogen gas, and we have taken equal quantities of the solutions. Finally 2 pieces of magnesium ribbon were taken with same length in this experiment, but what happened, in one test tube reaction taken place rapidly, another test tube reaction taken place slowly. The reason is nothing but 1:10 solution is more concentrated than the reaction, therefore proceeds faster. That means greater the concentration of the reactants, faster the rate of reaction, and the rate of reaction can be measured by the rate at which hydrogen gas is produced. So what is the meaning of this one is 1:10 and 1:20. If you observe in this preparation, we have taken 2 parts of water, that is pour 10 cm cube in one test tube and 20 cm cube of another test tube. So this hydrochloric acid we have added, that is dilute, and another one we have concentrated. So what happens, reaction is faster when it is in concentrated. That is the meaning of this one. So likewise, we have interesting factors in the activity, that is the effect of temperature. What will happen when the temperature increases about the rate of reaction? If you take the 4th and 6th groups, the design experiment that will help you to see affect the temperature and the reaction time of 2 cm of magnesium ribbon and 20 milliliters of vinegar. If you take during this group discussion, you should think about the following: what equipment will you need for this one? How would you conduct the experiment to make sure that you are able to compare the results for different temperatures? How will you record your results, and what safety precautions will you need to take when you carry out this experiment? And present your experiment ideas to set to the rest of the class and give them chance. This is for students. They're telling, once you have received the feedback, carry out the experiment and record your results. What can you conclude from your experiment? Finally, in this experiment, when you increase the temperature, what will happen? Rate of reaction increases. That means, whatever 2 centimeters of magnesium ribbon you have taken, then 20 ml of vinegar, when the rise in the temperature, definitely when you get the reaction rapidly, because the temperature increases, number of collisions increases, and rate of reaction increases will be the conclusion of this activity. Moving on to the next one, most important concept in this one is the reaction rates and collision theory. It should be clear that the rate of reaction varies depending on the number of factors, but how can we explain why reaction takes place at different speeds under different conditions? Why? For example, does the increase in the surface area of the reactants also increase the rate of reaction? One way to explain this is to use the collision theory, because to increase the surface area, there will be one more important theory needed to understand why the rate of reaction increases. For a reaction to occur, what will happen? There are some important factors are there as collision between the particles. So these particles that are reacting must collide with each other. Only a fraction of all the collisions that takes place actually cause chemical change. These are called as successful collisions or fruitful collisions according to this theory. When there is an increase in the concentration of reactant, the chance that reactant particles will collide with each other also increases because there are more particles in the space. So in other words, the collision frequency of the reactants increases. So the number of successful collisions will therefore also be increases. And so will the rate of reaction increases. In the same way, if the surface area of the reactants increases, there is also greater chance of the collision, that means happens according to successful collisions may occur. Finally, the products will be obtained due to these successful collisions. Let us understand what is collision theory's definition. Collision theory is a theory that explains how chemical reactions occur and why reaction rates differ for different reactions. And the theory states that for a reaction to occur, the reactant particles must collide, but only a certain fraction of total collisions, that are called as effective collisions, actually cause the reactant molecules to change into products. And this is because only a small number of molecules have enough energy and the right orientation at the moment of impact to break the existing bonds and form new bonds. This is called as the main theme of this collision theory. So when the temperature of the reaction increases, what will happen? The average kinetic energy of the reactants particles increases. There will be move around much more actively, and they are therefore more likely to collide with each other. That means there is an interconnectivity between temperature effect and these collisions that is discussed in this point. So increasing the temperature also increases the number of particles whose energy will be greater than the activation energy of the reaction. They will be converted into products. We can see the two simple diagrams here shown. In the first diagram, we have low temperature case. This is the particle orientation and all. When high temperature is there, means collisions possibilities, that means effective collision possibilities are increasing. Automatically what happens, the converting the reactants into products also takes place. That means reaction leading to takes place and also led to conclusion with fruitful collisions. And here in this we have observed a measuring of rate of reactions. How can you measure the rate of reaction? Another important concept here. Reaction that produces hydrogen gas. We have observed the magnesium reaction with sulfuric acid gives hydrogen gas. So to study this one, when a metal dissolves in acid, hydrogen gas is produced. A lead splint can be used to test the hydrogen. The pop sound shows that hydrogen is present. For example, magnesium reacts with sulfuric acid, hydrogen gas produces. That means there are simple examples to understand the rate of reactions. Another example we have, that is a reaction that produces carbon dioxide, that we observe, that is the Marple reacts with the hydrochloric acid, liberates carbon dioxide gas that we observed. Another one, we have reaction that produces gas such as oxygen and carbon dioxide, which is also an example when hydrogen peroxide subjected to decomposition to water and oxygen. So hydrogen peroxide decomposition produces oxygen. This is also another example in the study of rate of reactions. Precipitate reactions. We have thiosulfate reaction is there, that is sulfur dioxide and water and sulfur. Colloidal sulfur will be formed in the precipitate reactions. So on seeing all the different kinds of reactions, we can easily understand that the rate of reactions for all the reactions are not same. So this is the gas syringe method we can use to understand how much gas is produced from the reactants. The next thing is mechanism of reaction and catalysis. Earlier it is mentioned that it is the collision of particles that causes reactions to occur, and that only some of these collisions are called as successful collisions. This is because the reactant particles have a wide range of kinetic energy, and only a small fraction of particles will have enough energy to actually break bonds, so that the chemical reaction can take place. The minimum energy that need to a reaction to takes place is called as activation energy. Most important point here. For more information of these reactants, you can see the previous session we discussed about activation energy. Its definition that is called as energy that is needed to break the bonds is reactant molecules so that the chemical reaction can proceed is called as activation energy. Now you can see most important graphical appendix to understand this one. That means so even at a fixed temperature the energy of the particles varies, meaning that only some of them will have enough energy to be part of chemical reaction depending on the activation energy of the reactants. This is shown in this diagram. We have increased the rate of reaction temperature. It has an effect to increase the number of particles with enough energy to take part in the reaction, so that reaction rate increases. So you can see the graphical representation telling about the distribution of particles kinetic energies at a fixed temperature. Here, what is the role play of a catalyst? But a catalyst functions slightly differently. That the function of catalyst is to lower the activation energy so that more particles now have enough energy to react. A catalyst itself is not changing during the chemical reaction, but simply provides an alternative pathway for the reaction so that it needs lesser energy. Some metals, example platinum, copper, iron, can act as catalysts such as in certain reactions. In our own human bodies, enzymes are catalysts that help speed up the biological reactions. And catalysts generally react with one or more of the reactants to form chemical intermediates, and which then react to form a final product. The chemical intermediates sometimes are called as activated complexes in this catalyst mechanism. For a general reaction, so you see the following is an example we have, that is A plus B, A plus C gives to AC. That means entire mechanism is divided into 4 steps, elementary steps. How a reaction that involves a catalyst might speed up, might proceed. C represents the catalyst, and A and B are the reactants, and D is the product of the reactant. So here symbols given. A is converted into B in this. A is converted into D. In these steps, we have A plus C gives rise to AC, and B plus AC gives rise to ABC. And step 3, we have ABC gives rise to CD, and step 4, we got CD is converted into C plus D. So finally, whatever C catalyst we added, that is again came in the last step as it is. That means catalyst is not going to involve in the chemical reaction. How many grams of catalyst we have taken, that same amount of catalyst will come out in the step 4. So in the above, ABC represents an intermediate chemical that is called as activated complex. Although catalyst C is consumed by reaction 1, but it is later produced again by the reaction 4, so that overall reaction source A plus B plus C gives rise to D plus D, D plus C. In that C is the catalyst in the reaction, and D is the product. So what you understand here is, you can see from this that the catalyst is released at the end of the reaction is completely unchanged. Once again, we'll see what is the meaning of a catalyst. A catalyst is the speeds of a chemical reaction without being altered in any way. It increases the reaction rate by lowering the activation energy of the reaction. It's most important point to be noticed in the examination point of view. What is the role play of catalyst? Ask when you can tell this one. So energy diagram also they will ask in the exam, that you can write like this. Is useful to illustrate the effect of catalyst on reaction rates. Catalyst actually decrease the activation energy required for a reaction to proceed by a smaller hump in this diagram here. Therefore, increase the rate of reaction. See, in the presence of a catalyst, in the absence of catalyst, what happens is a thick line is there in the absence of catalyst, and dot line is there in the presence of catalyst. Thus, activation energy definitely decreases in the presence of catalyst. So this is called effect of catalyst on the activation energy of a reaction. Catalyst and reaction rates. There are so many activities are there we have to determine the effect of catalyst on the rate of reaction. There is a small experiment is there. This experiment needs zinc granules and 0.1 hydrochloric acid, copper pieces and one test tube and a glass beaker. These are enough. So in this method what we'll do is we'll place a few of the zinc granules in a test tube. After that we'll measure the mass of a few pieces of copper and keep them separate from the rest of the copper. About 20 centimeter cube of HCl will be added to the test tube, and you'll see the gas is released because zinc and HCl, which gas? Hydrogen gas will be released. And test, note that how quickly or slowly the gas is released. Write a balanced equation, then after that the balanced equation will give hydrogen gas. Now add the copper pieces to the same test tube, and what will happen is the rate at which gas is produced. Carefully remove the copper pieces from the test tube and do not get HCl in your hands, and rinse them in water and alcohol and then weigh them again. Then has the mass of copper changed since start of the experiment. So what is the result you observed in this experiment is nothing but the gas that is released is the hydrogen gas. No doubt at all when zinc reacts with HCl. Rate at which the hydrogen is produced increases and the copper pieces are added. So the mass of copper does not change during the reaction. So here what happened is nothing but copper pieces, whatever we are adding, the copper pieces acts as catalyst in this reaction. They will increase the rate of reaction. So catalyst definitely increase the rate of reaction. What is the conclusion of this one is copper acts as a catalyst during the reaction. It speeds up the rate of reaction, but it is not changed in any way itself. That means initially we weighed the copper pieces mass, and after the chemical reaction, that means liberation of hydrogen gas, we have separated out the copper pieces. Their mass remains the same. Okay, this is all about the different important activities regarding the chemical reaction rates. Thank you very much. We'll meet in the next session with problems and graphical representations. Thank you.